let's start over here. So here it says, draw a straight line from each function to the correct plant cell. Draw only 2 lines. Remember to read your questions very, very thoroughly. So we have some functions over here, and then we've got some plant cells. So these look like some ground cells. This looks like just a normal sort of palisade cell from a leaf. This is a little root cell, and here we've got some transport cells, which you can find in a stem. So let's see. Absorbs water and minerals from the soil. So this is obviously a root cell. So you would draw a line like that. And then transports water and minerals, that would be that one. So this question is fairly straightforward. Where you would get your marks is literally just for these 2 lines. They will, however, subtract marks if you draw extra lines, since they told you to only draw 2 lines. Okay. So here we go. Reactions between metals and non-metals form compounds. Sulfur reacts with metals to form a kind of compound called a sulfide. Complete the table below to show the type of compound formed by different non-metals. One has been done for you. So sulfur reacts with metals and formed sulfide. So that is our hint over here. So sulfur becomes sulfide. So oxygen will become oxide. Is it oxide or oxide? No. My spelling. And then chlorine will become chloride. And those will be your 2 marks. So iron reacts with a compound and oxygen to form rust. What is the name of this compound? So this is literally just iron oxide. I can't remember what I think it's FeO2, the name, but it's literally iron oxide. Like that. So this is fairly easy questions, not too difficult. So here we get to things where we actually need to remember things. So Gabriella connects an electrical circuit. Here it is. There are 2 lamps and 4 ammeters. The lamps are identical. The reading on A1, so this one over here, is 0.8 amps. What are the readings on the other ammeters? Okay, so here we need to remember the difference between parallel and series circuits. In a circuit that is in series, our reading on our ammeters will all be the same, but in a circuit that is in parallel, our reading on our voltmeters will all be the same. So here we have 0.8 amps. This part over here is still in series with this bit, so this will also be 0.8 amps. But here, the circuit gets divided into 2 parts, and since these bulbs are identical, it would literally just divide it into 2. So this will be 0.4 amps and 0.4 amps. So now we just need to go write it down into here. So A2 is this one, so that'll be 0.4. A3 will be 0.4, and A4 will be 0.8. Okay. So the trick here is that series circuits are the voltage will be different over each component, but parallel circuits, the amperage will be different over each branch of our parallel circuit. So I don't think I've covered this in a lesson yet, but I will do so. So here I want you guys to notice that there's only 2 marks. And there are 3 answers over here. So in terms of this, they would collectively give a mark for this bit, and they would give 1 mark for this bit. So this is to see that you know that it stays the same if you're still in a series bit, and this is to see that you know that it divides when you go over parallel parts. So they're testing to see whether you know the knowledge, not whether you get the correct values. So that's where you will get your marks. Okay. So this diagram shows a frog. Scientists classify animals with backbones into 5 main vertebrate groups. Classify the frog into its correct vertebrate group. Okay, So give one reason for your answer. So our vertebrate group here is our amphibians. That's what our frogs are. And amphibians are classified with the reason that they're young, grow up in water, but when they're older and mature, they can go on land. So we just need to write that in neat words. So they lay eggs and grow up in water. For adults, they live on land. There we go. So here you would get 1 mark for amphibians and then 1 mark for your reason. Here's a bit of a more difficult one. So Rajiv draws pictures of the stars in the night sky from his bedroom window. He draws a picture in January and then a picture in June. Okay, so some of these stars stayed the same. So let's just continue reading. Write down one difference between the 2 pictures. And then he draws another picture in January of next year, and we need to see what the picture would look like. Okay. So this star and that star stayed the same. That one stayed the same. This one is different. Those stayed the same. That one stayed the same. Those stayed the same. Those stayed the same. So now we need to see where these other stars moved to. So this one moved upwards to over there. From January to June. So in June, it's over there. Actually slightly lower, but that's okay. This one, from there, it moved to over here. This one from here, it moved to over there. And what else do we have that's different? That one's the same. Those are the same. Those are the same. Okay, so we've got this star here, which moved to over here. And then lastly, we have that star here, which moved to over here. So now we can see sort of what has happened here. So this is obviously a picture of some kind of planet with its moons, just due to the fact that we can see these stars wandering. The definition for planet means wanderer in the old language. So we see here we've got a planet, and then we can see how these have moved. So write one difference between the 2 pictures. So just one. So we can just write about the big star. Big star moved to the left. Okay. So now we need to describe what this picture will look like after another 6 months. So January, June, and then again in January. So now we can think of how these have changed. So this moved to over here. So it's probably going to end up being right over there. This one moved to here. So it's going to end up being over here somewhere. This one is going to move a bit further and end up somewhere here. This one's going to be completely off of the shot. And this one, which moved over there, is probably going to end up being somewhere over here. So this looks remarkably complicated, but it is okay. So now we need to find a way of describing these stars. So we can number these stars or circle them, and then we can describe there by saying the circled stars will stay in the same position. Or you can say the first, second, third, and so forth stars will stay in the same position, and those 5 stars will move to different positions. So let's start with just one of them. So this big star will continue moving towards the left and will be on the edge of the picture in January. Edge of the picture. Okay. So this is only 1 mark, so they are not going to look for a ridiculous amount of explanation. They're probably going to look for 1 or maybe 2 points that you have thoroughly, nicely explained about how these are going to change. So let's look at this one over here. So let's see how to describe this one. The slightly medium star that started right next to the at the right will have moved off of the picture. So we can describe that. We can describe which stars will be standing still. So you just need to include 1 or 2 points of how these things have moved. And that is pretty much it. So the marks will be given for whether you can see the pattern in how these things moved at that question. So here we go. Question 6, name the process that plants use to make their own food. So this is photosynthesis. Name one other product of this process. Oxygen. Okay. So here we have, in an investigation, identical plants are placed in 3 gases. 3 different gases. So they've got this and then 3 different gases. It's given constant light and they're kept in the same conditions for a week. Okay. So the only difference is the different gases that they gave. So here we have the results of the investigation. So this one grew larger, this one stayed the same, and this one started drooping and dying. Okay, describe the results of this investigation. The plant kept in gas A, so now we just literally need to describe this, grew bigger. The plant kept in gas B wilted and started dying. The plant kept in gas C stayed the same, essentially. Here, 3 marks, 1 for each of these, just to see whether you can describe what has happened. Okay. So here we can also say, instead of just wilted, we can say, instead of stayed the same, did not grow but stayed the same. Here, grew bigger, sort of things. So just use some descriptive words. It is perfectly fine. So Carlos investigates the reaction of zinc with dilute sulfuric acid. He puts zinc into a conical flask over there and then adds 25 cubic centimeters of cold dilute sulfuric acid. So this is his apparatus. He then records the volume of gas in the syringe each minute. So that's after 1 minute, after 2 minutes, after 4 minutes, and after 6 minutes. So the volume of gas collected after 6 minutes. So that will be 40 cubic centimeters. I've already got the cubic centimeters. We just need to literally go read that off. So he repeats the investigation using 25 cubic centimeters of warm, dilute sulfuric acid. So predict the volume of gas collected after 2 minutes. So here what they're testing is to see whether you know that temperature affects the rate of a reaction. So here it will be marked right as long as it's larger than 40 centimeters. So you can write 60 centimeters, cubic centimeters, we can write 80 cubic centimeters, it will be marked right. As long as it is bigger than 40 centimeters, it will be marked right. In the memo, it will say something between mark if between 50 to 100 cubic centimeters or something. Okay, Carlos then repeats the investigation using 25 cubic centimeters of more concentrated sulfuric acid. Explain why the reaction is faster. So here what they're testing is whether you can explain, probably using particles and collisions. Yes, use ideas about particles and collisions in your answer about why this reaction is faster. So here we can use a direct comparison. It works a lot better. So in the original experiment, moles of sulfuric acid in the solution is more spread out. Okay. And now we can say in the more concentrated, I'm not going to write that out, sulfuric acid solution, the particles are closer together. So there are more particles that are closer together, so they will collide much more with the zinc. It is zinc. Zinc. So there are more particles closer together and will therefore collide more with the zinc. Okay, my handwriting is very big on these tablets. So here we have a picture showing the air particles in front of a loudspeaker. So write the letter C where there is a compression of air particles. So that would be here. And write the letter R where there is a rarefaction of air particles. So you can write it in any point. I just wrote it in 2 places. You only need to write it in 1. So 1 mark for the compression, 1 mark for the rarefaction. Okay. So here we have a mountaineer climbing Mount Everest. Mount Everest is nearly 9 kilometers high. The air pressure at the top of the mountain is very low. This makes breathing very difficult. So the mountaineer wears a tight-fitting mask connected to a breathing apparatus. A chemical in the breathing apparatus removes waste gas from his breath. So, name the life process which provides the mountaineer with energy for climbing. So this is respiration. Is literally the act of breathing, getting oxygen into your body, and then your cells will use that oxygen along with some stored or gotten carbohydrates in order to turn it into CO2 and release some energy. So that is what gives your body energy is literally your respiration. Okay, which gas found in the air is needed for this process? Oxygen. Which gas needs to be removed from the mountaineer's breath? This will be CO2, so carbon dioxide. They will also accept just CO2. If you write this, it will be accepted. So suggest why low air pressure at the top of the mountains makes breathing more difficult. So again, here they want that particle explanation. So at the top of the mountain, there are less air particles in a set volume. So whenever you breathe in, there will be less air particles being taken in. There is a question. Do we always need a breathing apparatus when climbing a mountain? We don't necessarily always need a breathing apparatus when climbing a mountain. It's only if the mountain is especially high. So Mount Everest, you do need breathing apparatuses. There have been people who climbed it without them, but that was years ago and they actually suffered quite a bit of damage. So other mountains that you will need breathing apparatuses for is places like Kilimanjaro. There's a few mountains in, what's the name of that mountain range? It's okay. So only if a mountain is very high, where the air actually starts thinning out beyond the point where it's easy to breathe, that you will need a breathing apparatus. Okay. So here we can write, there are, air particles in a volume of air. So certain places in the Alps, yes, the Himalayan mountains, there are certain Himalayan mountains where you will need breathing apparatuses. Certain places in the Alps, it is recommended. So it's just really, really high mountains, exceptionally high mountains that you will need breathing apparatuses. Okay. So if you breathe in, you will inhale less. Okay.